Hello, 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 everyone. How's it going? Long time. No, not long time. But welcome back. Welcome back after our 1 hour break that we had. Uh, I hope you had your lunch, dinner, breakfast, whatever the time it is. And yeah, we are into the end game now, which is basically our final and fourth part of machine learning using JavaScript. First session, like very quick recap. First session, we basically saw the usage of Tesseract JS and also TensorFlow JS. Yeah, hello, hello, hello. We saw the usage of Tesseract JS and TensorFlow JS, TFJS, uh, to basically read text from an image, the which took 2 sessions, 2 hours each, so 4 hours of that. Then today, in the first session, we used a pre-trained model called as Coco SST, which is an object detection model, and we had some fun with it. We actually saw that it could recognize the house plant that I have, uh, which is really nice. It could recognize a dining table in a classroom, which definitely did not exist, but as per the object detection model, it did. And hey, hi. Uh, so yeah, that's what we did in the first bit of today's session, which was part three. And now the final part. And as promised, uh, we will basically run uh, some code and build our own model. But before we build that, we will also build our own data set. Okay, so that is the best part. Like, we'll learn how to make our own data set. If you remember day one, first session, we went over that PPT where I was like, what does a typical ML workflow look like? And there was this part about gathering the data set. And once you have the data set, you have to clean that data set, a bunch of that stuff, right? So today, first part would be to create our own data set. Then we will work on, like, and I will not create everything. Probably we will skip to the good parts. uh, but yeah, I'll still, like, basically we'll reach to a point where I'll be like, okay, this is how you create your data set, and this is what you can do, this is how you can increase your data set, and blah blah blah. Okay, so once that is done, we will then write some code to build our own model, where we will learn, like, maybe not in depth. Okay, and I'm very sorry about that. Because it's just not possible, I feel. But we will write some pieces of code, and some pieces of code, like, I was already, as I had said, that I would kind of rewrite it before we start this session, so that you all, like, I could, just show you around what each and every line means, kind of. Okay, so that we don't have to spend too much time going in depth of it. So yeah, uh, we will then write some code to build our own model. And once even that is done, then we will write some code to use this model in a React application. And yeah, we'll work out from there. So yeah, I hope you all are ready, and let's get started. We have a couple of folks joining, so I think this should be good enough. Okay, so I should delete this REPL, because there's actually nothing in that. For some reason, I ended up, wait. Yeah, I ended up creating that. Ignore me. So create a REPL. We will go with React JavaScript, and we will call it as create your own ML data set. Okay, so it's a React application. And what are we going to do? We are going to use our favorite tool, which we have been using since, I think, yesterday, which is Canvas. Okay, so what are we going to do? So on Canvas, we are going to draw. Okay, we are going to draw some shapes. Then we are going to download those shapes locally and store it. And once we have it downloaded, then we are basically, like, we'll create one shape multiple times. Let's say uh, some simple shapes would be triangle, rectangle, square would be very difficult on canvas. But triangle, rectangle, circle, I think these are some good enough shapes that we will basically look at. Yeah. So yeah, we'll create those shapes, we'll download it. We could also create shapes like trees and I don't know, bat, like cricket bat, uh, some basically simple shapes. Okay, and we'll download those shapes, we'll save it locally. That will form our data set. Then we will take those shapes and then do some magic in a way, and use TensorFlow to create a model which should basically read the data set, the data set that we have created, and then it will create something called as a model, and we'll use that model in the UI. So enough talk, let's get started. Step one, create a quick application if you haven't already. If you're doing it locally, please run the npm create vite latest stuff. Deleting a bunch of stuff from here, don't need this, so deleting that as well. And I will be going a bit quickly in this one. uh, yeah, so please bear with me. .jsx does not need this. And what can we do? We can create a new component. So we can call it a draw component .jsx. Okay, so creating a new file, draw component .jsx. That is where we will draw everything that we uh, yeah, where we will download our dataset, create our own images and download our own dataset. Okay, so moving along, step one, import React from React, and const draw component equals to, will not take anything, would be empty. We can just do a quick return here saying that, oh, there's a div tag. Inside the div tag, there's a h1 tag which says draw images. Okay, and finally we'll do an export default draw component. Okay, formatting it out, going into app.jsx, and right here we will call the draw component. Perfect. Formatting this one as well. So we have a draw component which does not actually have anything on it right now. All it does is write the text draw component, draw images, not, no, sorry, draw images, not draw component. uh okay, now inside this draw component, that's where the magic will start. So step one, we will use canvas ref. So const canvas ref is equal to use ref. This would be something new, like we have used use state. So what does this mean? Initial value is still null. So a ref is kind of, you can think of it as a reference to certain variable. Okay, so uh, in use state we had two variables. We had a variable name comma set variable name. Okay, something of that sort. In a ref you have one single variable, const like canvas ref, and all it does is says that, oh, this the like this canvas ref dot current has the reference to the data. Okay, it has the reference to the data, and yeah, that's what basically we are going to use. Don't need to get into it. We could have used use state if we wanted, actually, I think. Yeah, so const some state variable is drawing comma set is drawing. Okay, so this is a state variable which we will say will store whether the user is drawing on the canvas or not. Okay, Let me reduce the size of this, format this one. Uh, okay. And then next bit would be to write some functions. So the first function that we are going to write is const start drawing. Okay. So that will take a event. You can write it as event or even shorten it to E, okay, if you want. And we will say const canvas equals to canvas ref dot current. Okay, so reference to this canvas which we will create inside the return very soon. uh, then you remember the ctx, that is the context. We will say that canvas, which is this variable here, dot what was it, get context to a 2D context. Okay, so this is a 2D one. Then ctx dot begin path. So this is what allows you to draw on screen. Okay, and ctx dot move to, and this would be like event dot native double dot, sorry, native event dot offset x. Okay, and event dot native event dot offset y. So what this basically means is when the user starts to like draw, they will take whatever wherever the mouse is, and like from there, from that point onwards, they will start the drawing, and whatever is the x-axis and the y-axis of the mouse pointer at that time, that is where the drawing would start. So then we should set the is drawing. So is the user drawing would now be true. Okay, ah, wrong. So initially user is not drawing, of course, and we will say that there is this start drawing function which we will use, and whenever the user clicks, does a left click, that's when the start drawing function will be invoked, and wherever that left click has happened, that's where you will say that, oh, this is where the pen is going down. You can think of it as a pen down. So pen down being like pen down on the screen. Okay, so that is where you will say that, oh, that's where the user has started drawing. At this stage, at this point, the user has started drawing. And now we should write the draw function. So const draw equals to, again, this would be event. I'm going to shorten it to E. So first of all, if not is drawing. Okay, so this is like early return. We are doing an early return saying that if the user is not drawing, or there is no, if this is drawing is false, in that case, don't don't run anything that is inside this function. But if that's not the case, if the user is drawing and the value of is drawing is true, then what we need to do? So step one would be, remember the canvas. Okay, so store the reference to the canvas in this variable called as canvas. Okay, another way to explain a ref is to say that, hey, this is the HTML element where you need to make changes. Okay, then context, it's going to be a 2D context, of course. Then what else? We need to then tell it like this was the move to. Okay, which basically meant that this is the starting point, but then we use the line to. So ctx dot line to, and you can check the mdn reference by clicking on it. So dot line to method is a part of a canvas api, adds a straight line to the current subpath by connecting the subpath's last point specified. So you remember the last point would basically be where the mouse went down, like, someone clicked and started dragging. Okay, and that is where the start drawing basically started. So it will start from there, and then we'll also need to add the stop drawing, of course. So ctx dot line 2, this would be e dot native event. So native being like browser event. Okay, so this is a api that the browser is giving you, kind of. So you don't need to actually calculate where the mouse is. If you do this e dot native event, uh, that contains the variable where the mouse is, then we will say that this needs to be a stroke or a line or a straight line, kind of. Then we can also set the width of the line, so like how thick the line is going to be. So I'm going to keep it at 3, and you can make the line smooth by making it rounded, making the line join rounded, but I'm not going to do that right now. Okay, not really required. So we have two functions, start drawing, we have the draw, and then we will create one function called as const finish drawing, where we will say that the set is drawing is going to be false. Okay, simple as that, nothing else. So whenever this is false, this function will return automatically, right? If the mouse is hovering in the canvas but you have not clicked it, if you have not clicked it, then the start drawing is basically uh, has not set the is drawing to true. So if it is not drawing, then this function will not do anything. And the drawback is that if you click on the screen and then you move your mouse around and then you come out of the box, okay, we'll create a box, a canvas box, and all the drawing will take place inside that box. If you come out of that box without clicking back again, the set is drawing is never false. So it will, if you go back in the box, it will continue drawing. And like I can show that to you like in a second. uh let's create this. So this div tag, I am going to add some inline styles, and I will say the text align should be center, and from the margin top it should be like 20 pixels down. The center needs to be wrapped in this, and yep, perfect. So this is this, and then draw a shape and download it. Okay, we have not written any code to download it, so we'll come to it, don't worry. Let's create another div. Inside this div is our canvas. Okay, now this particular canvas is the HTML element canvas, and this is going to be self-closing. Okay, now let's start giving it some attributes. The first attribute is ref. Okay, so ref is equal to our canvas ref that we had created right here. Okay, then you can set the width and the height of the canvas. So I'm going to say that the canvas should be 64. Okay, the width should be 64, the height should be 64 again, so 64 by 64 box. Then we can style it by saying that there needs to be a border around the canvas, could be 2 pixels, solid, and black color. Okay, nothing too fancy. Let me format this whole thing. Now we need to tell it when the user clicks something, so that is on mouse down, you should start drawing. Okay, on mouse move, you should call the draw function. Okay, because inside the draw function is where we tell it to make a line of this much width. And then on mouse up, okay, that is when you need to finish drawing. Yeah, I think this should be good enough. Now, if I go over to this is the box that we create. And now what I am doing is I'm creating a shape. Oh, there was this on mouse up. So I think it should, yeah, it should actually stop. But we should also write some clear function and all. This is too small box. So instead of 64, we can do it 128 cross 128. Yep, bigger box. So triangle. Okay. We should actually give it two buttons. One is to clear this canvas because reloading all the time does not make sense. And we should also give it a download button. Okay, so these are the two other things that we should add. So let's do that. But other than that, I think this is a very good thing to learn. Uh, how to use canvas and how you can draw your own shapes in canvas. So it's like a good pastime. Just create this. Like you can create a website where users can come and just like make some random images and then download it or clear the canvas. Okay, very simple. You don't need to ask user to sign in or sign up. Just have this website out there for users to freely come and just draw some shapes and download it. Okay, nothing too fancy, very simple, but yet very effective, I would say. Okay, a very good pastime. And you will have something deployed for public to see and use, which is, I think, really nice. uh okay, so I'd forgotten what I was doing. So let's create a clear canvas drawing. So const clear canvas. This function is going to be const canvas equals to canvas ref dot current. You all know what this is doing, and then you know exactly what's the next line going to be. Okay, so const ctx is going to be canvas dot get context of 2D. And then to clear the canvas, actually all we need to do is ctx dot clear rectangle 0 0, which is what's the x-axis, what the y-axis. So like which part. So we want to create delete basically everything, and then the canvas dot width, so the whole of the canvas, and the canvas dot height. Okay, so whole of the canvas. So this is our clear canvas button. Let's also create the download button. So const like download function, sorry, not button, download image function. And this would again be arrow function. I'm going to now copy paste this. Yeah. But actually we don't need to get the context, I feel. Yeah, because it's not really required. We are not going to change anything on the canvas. What are we going to do is just take whatever is inside that bounding box and download it, right? uh, yeah, so const link, let's create this one, document dot create element. Okay, a tag, we are going to create a tag. Then we are going to create a label, which would be a prompt. Okay, what is a prompt? You remember, you know what is an alert? It's a box that comes out from the browser whenever you like, sometimes you get these like this website wants to access your location. So that is like an alert. And you also have the option of a prompt which you can give a input to. So enter shape name. Okay, so this is our label. Okay, this is what the model is going to use, the label for creating its own, like it's going to use the data set and the name of the file as the label. You remember from supervised learning discussion that we were having, you need to have a label. And then we are going to say link dot download. Okay, link dot download, actually it won't be a function, and this is going to be equal to, we are going to use backticks, and we will say that the name would be label dot jpg. Okay, it's a jpeg file. You can also download it as a png file. uh, it's on you actually. Then link dot href is going to be canvas dot to data url. Okay, so the default is PNG, but I am sure there must be something for JPG. I will need to check. Command F PNG. Okay, so there is image slash JPEG, JPEG, not JPG, JPEG. So okay, so that's what I'm going to use. I'm going to say that it is JPEG. Also on the link to download, I am going to change that to JPEG, and then there is a link dot click. Once you see it in action, this thing will make more sense. So we have created two functions. One is to clear the whole canvas and one is to download the image. Let's start using it. So there was this div which was wrapping the whole canvas. We are not going to touch that. We will add some, let's add a break tag. And after this, let's add a button where on click of that button, it should clear the canvas. And we will actually name it as clear canvas, right? Then again, a break tag and then another button. So I'm going to copy this. I'm going to paste it right here. And this would be download image. Okay, so two buttons. Let's go over here. So let's say I start drawing. I draw a shape. I click on clear canvas, deletes it. Okay, shape again, clear canvas, and shape again, and download image. So you see it gives you this prompt, enter shape name. So you give it a name and then you can click on OK, which will download it. So I'm going to click on cancel for now, and still downloads it. So I should basically write something for it, but I'm going to ignore it. Okay. Like maybe if the user clicks on cancel, you should kind of ignore the prompt. So for the label link, yeah, I think I'll have to keep a track of that. So in prompt, let me see if there is some idea about the window.prompt method. There is a prompt message. That is what we are using. And what does it return? This function returns null. So we can go like if label not equal to null, in that case, you should do all of this. Yeah, I think that makes more sense. Also, let me change my folder directory so that I don't get doxed. So remove this. I am going to download click cans. Okay, and I'm going to save it in Okay, give me like 1 second. Basically changing the folder. Yep, done. And I'm back. I mean, the screen is back. Okay, so if label is not equal to null, in that case, we will do all of this. So if you remember, now if I clear, like, let me reload this whole thing. I draw a shape, I click on download image, but I don't do anything. I like, or even you can do this, click on cancel. It will not prompt me to download it. Okay. So yeah, that was a good quick check of how to resolve this. Okay, this is the part that helped me. If the user clicks on cancel button, this function returns null, and we are saying that if it is not null, then do all of this. Okay, sorry, got lost a bit. Let's add some more break tags. I mean, actually we could have added a div tag around it and styled it and stuff, but now I'm getting just lazy. Okay, more space in between these. I think 2 should be good enough, actually. Yep, clear canvas and download image. Uh, Canvas size, I feel like could be 256 cross 256, could be better and bigger. Yep, clear canvas, and let's style the button quickly. So I am going to write a style equals to style double curly brackets, and let's style it very quickly. What should we add? We should basically add some background color to it, right? So background color to be, there's something called as crimson, so which is red basically, fancy name for red. If the background is dark red, the foreground color should be white. uh, the text color, we can add some padding to the button, like 10 pixel padding. uh, Border radius, border, if you want, like I don't want the border, so border none. uh, and cursor to be pointer. And yep, that is good enough formatting. There we go, clear canvas. Okay, I think a border radius would do it nice. So border radius of 5 pixels, then a comma here. Yeah, so clear canvas. And the download image, I'm going to copy the exact same style. We'll change the color. So background color could be blue. Like, there's a sky blue, dark blue, Alice blue, cadet. Oh, wow, cadet blue. Uh, Padding this time, I want this button to be bigger than the previous. Focus. Okay, so clear canvas, download image, and you draw a shape. You click on download image, and okay, there's a good suggestion. You can make it green. Yeah, I think cadet blue looks kind of green. There's dark green, lawn green, lime green, pale green. I wonder what that looks like. Does not look pale. I mean, it just looks white. Ew, that's bad. Sea green. Ah, finally. Okay, so yeah, that's red, and this is green. Okay, and now if I draw a shape and click on download image, I give it a name. Example, this is 1 dash green. Not green, sorry, triangle. Okay, I click on OK. It prompts me where do you want to save it. I want to save it inside this folder, and it downloads it. Now let me see if I can actually check it out. And it's empty. Why? Interesting. What if it's a PNG image? What happens then? So PNG. Uh, why am I? Okay, let's say a triangle. Download image. The shape name is 2 dash triangle. I click on OK. It downloads it there. And okay, the triangle looks pretty sure there was something there, right? Yep. Hmm. I wonder why. Maybe it's the background? Yeah. Yes, exactly. We kind of arrived at the same conclusion that the background, I think it needs to be white. Okay, it needs to be set to white. So where can I do that? I think it should be here somewhere. Canvas background, but I'm not too sure how to do that. So I'm going to do it. Okay, apparently that's there's a width, there's a height, there's a oh, can I use the fill style? If I do a fill style, so ctx dot fill style equals to white. If I do that, what happens then? I reload this whole thing. I make a triangle, click on download. This is 3 dash triangle, click on OK, save it, and nope. Okay, that doesn't work. Okay, just that does not work. Where's my? Can I give it a back? Not too sure. Background color of white. And what else exists here? Stroke style white. Wait. Oh, stroke style white will make this in white. But I want to see how do I set or actually this part where it was the ctx dot fill rectangle. If I do that, what happens then? If, let me format this. Okay, so now the fill rectangle 0 0 canvas width canvas height. Okay, let's see. This is 4 dash triangle. Click on OK. Yep, save it. Let's see. Okay, could do it this way, but I want to do it the other way around. I would prefer the so stroke style should be black, the fill style should be white, and that should work, right? Clear reload. Okay, click on download image, 5 dash triangle, and save. Whew, finally, nice. That was some good shout. We just did it the vice versa of it. And yeah, you were right. There was something. But so what would be better from the training perspective, I wonder? Like a PNG image without any background with just the text, would that be better? Or an image with a white background with a black line on it, would that be better? I'm not too sure. I will leave that on you. And yeah, that was some good debugging. Thanks, folks. Uh, okay, what else? Let's now. So, what are we going to do? We are first going to clear what I have here. So, all of this goes to bin. Perfect. And now we are going to create some shapes and download it. Okay. Now, remember from the perspective of, wait, what happened? Oh, on mouse up is finished drawing. And if it's a finished drawing, the set drawing is false. Where are we clearing the canvas? Oh, is it? Oh, it's because of this. Oops. I don't think this is where it should happen. Okay, I'll have to look into this. So what I was trying to do is I was going to lift up the mouse, okay, but then it clears the bottom bit because it kind of fills the rectangle again with white. Like I could show that to you with, like, let's say if this is green, uh, you make one thing, then you have lifted up your mouse, you've roamed around the whole screen, and you come back, it draws a new green on that. Okay, so that's a bad idea. So this is definitely not a very good way to do it, but I'm not sure what's the good way to do it, or at least like I'll have to experiment a lot with this. uh, So we will try and create shapes where we don't have to lift up the mouse. But during the break, I will quickly Google stuff and see how can I ensure that the background remains white and you can kind of lift up your mouse. I'm pretty sure there must be something, just something that I'm not remembering right now. Mm, how do I do that here? Mhm. Bad idea. Okay, for now, let's try and build shapes where you don't have to lift up your mouse. So like a triangle would be nice. A rectangle, I'm not calling this a square. Definitely does not look square enough, but a rectangle would be nice. A circle should be fine again. What else? Triangle, rectangle, circle, not square. Uh, could teach it about trapezium, I would say. Not a good idea though. We could teach it about a line. Okay. Oval, uh, I'm not too sure. Like from the model training perspective and the way we draw, oval would count more or less into circle, I feel. A hexagon, yeah, could do that. If you can make it without lifting up your mouse, definitely go for it. Okay, but I'm going to stick to some basic shapes for now, before like I figure out what's the problem with lifting up the mouse and how can I solve it. Till then, I'm going to stick with some basic shapes. And okay, so what you have to do, okay, we can take a 15-minute break this time. And in those 15 minutes, what I would want you, or I would request you to do, is draw the shape. Okay, draw a shape, download image. Example, let's say this is one dash triangle. Okay, and then save it in a triangle folder. Okay, save it there. And similarly, then draw different types of triangles, like at least 15 to 20. I would say do at least 20 of them. Okay, so different styles of triangle like this, or inverted kind of. Okay, I mean, you get the idea, right? Draw 20 different. Okay, let me come back on screen. So draw 20 different triangles, 20 different circles, uh, 20 different rectangles. Okay, so once you have done that, you have your data set of 20 shapes into three kinds of shape. So 60, right? And that is the data set that we are going to use, this very small data set that we are going to use to train our model. Now, model will definitely not be accurate. Okay, let me kind of guarantee you on that. Uh, Either it would be overfitting or it would not be accurate. So it would be like, I don't know, 50% accuracy or something, maybe less. Uh, but I think it would be a good learning point to kind of make this data set, download it, and then use that data set to create the model and train on that model. Okay, so for the time being, uh, this is the perfect time to take a 15-minute break, and in that break take 5 minutes to, I don't know, have some water, walk around, freshen up basically, and the next 10 minutes in making the shape and downloading it. Okay, and you will have the access to this code. My bad. uh, Here. Okay, so you can access the code that I have here. And yeah, if you have not reached that point. And yep, that's it. Once done, even I'll do the drawing of the shapes in the break. Uh, so I will like kind of stop screen sharing and yeah, quickly draw shapes and save it and stuff. And also experiment with that fill style and fill rectangle, see what can I do with this. And yeah, then we'll be back. How long will the class go on? So 1 hour 10 minutes, like 1 hour 15 minutes, where the next 15 minutes is the break, and then 1 hour more. So from UK time it would be till 4 p.m. Yeah, 4 p.m. UK time, 4 p.m. BST, British summer time right now. Okay, cool. Thank you so much, everyone. Quick 15-minute break. Please make the shapes and download it for the data set. Okay, very much important, because once you have that, then we can do the training. Hey, hi. Yeah, good. uh, yes, part four, the last one, unfortunately, but glad that you're here. Okay, 15-minute break, and then we'll be back. Cheers, everyone. Oops. I got lost in downloading the images and fixing that background color. Okay, and I found a Stack Overflow answer for that. So apparently it needs to be inside a use effect hook, because the background needs to be set on the first first load. So this is the updated code. Yeah, so it needs a use effect hook, like checking out JavaScript, won't redraw anything and stuff. So yeah, it needs to be inside a use effect hook, it seems. And what happens is that you basically, inside a use effect, you tell it that the fill style needs to be white. It should fill the whole of the canvas, whatever your canvas context is, with white color. And this effect needs to run after the canvas has been loaded in the DOM. Okay, so yeah, once that is done, then you set the color to white. And also, when we are clearing the canvas, we should also fill it with white color. Okay, on clear. So now, as you can see, I was able to lift up my mouse and then like roam around the whole screen and come back and then draw, and it is not clearing it up. Okay, and if I clear canvas, it's back to white. So now you can draw Christmas tree. Okay, uh, nice. So yeah, I was just doing that quickly, and we have the data set. I actually managed to download two things. So triangle, 20 images today, uh, and circle, 20 images. Okay, so this is what we have in the data set. Now I am going to create a new folder, call it training underscore data. And I am also going to create a new folder on my local called as testing underscore data. And what I'm going to do is I'm going to copy like the first 15 of the circle into training data. And I'm going to copy the first 15 of the triangle into the training data again. Okay, so this is basically now 20, 30, 15, 15, 30. 30 of it, and the remaining 1, 2, 3, 4, 5. So 5 from this into testing, and the remaining 5 from here into testing. Okay, so yeah, we are creating two folders. One is of training data, one is of testing data, and we are going to pass this to our model. Okay, once we start creating the model, we are going to pass this whole thing to the model to tell it to learn and train from these data. So I'm going to stop this. I'm going to go to home page, and I am going to create a new REPL. Now this is going to be a plain JavaScript file. So I could do it in the React one, but I would like to keep it separate. So I'm going to search for Node.js. I say pure JavaScript, but it would still require us to download the libraries, right? So that is why a Node.js project, because there is a TensorFlow node library available, which allows us to create a model using TensorFlow in Node.js. Okay. So I'm going to name this as create ML model using TFJS node. Okay. So currently empty file. Now in this case, I am actually going to spend kind of less time in explaining uh, each and every line. Like I'll try to explain my best, but we will still kind of skip over a few things because we don't have too much time remaining for this whole thing, and this is like huge file. Okay, like I actually was testing it out a while back, like an hour ago, and it's like 200 lines or something. It loads. No, 100 lines. Okay, so yeah, I was trying it out. I was checking if it will run on Replit, and fortunately, I was able to run it on Replit, but it's still too much. Okay, 100 lines of code where half of the things kind of bounce overhead. So yeah, we'll keep it quick so that once the model is ready, you can use it to kind of like we'll deploy it. Okay, we'll create a new React application where we'll use the model that we created. Uh, okay, so let's get going. I am going to go away from screen, and I am also going to share this. Uh, a notebook needed to train data, that would be in Python. We are doing this in JavaScript. And is TensorFlow enough? Yes, actually TensorFlow JavaScript will give us enough libraries and access to enough activation functions that we could use it to create a model, a simple model. Okay, so it's not going to be very sophisticated, it's not going to be perfect, it will not have like I don't know 100 not 100%, even 90% accuracy. I'm not too sure. Like if we reach even 50%, that's good enough. Like it would be big enough. uh, but yeah, just to learn how to do it in browser would be like really nice. How to do it in not browser, in Node would be really nice, in JavaScript basically. And if not that, then yesterday I was sharing about the different other libraries that are available, like brain.js, ml5.js, and convnet.js, and keras.js. So once you get an idea of how to do it, you could use any other library to do it. uh, is what I understand or feel. uh, okay, so let's get started now. Is this a type module? uh, Actually no. So we are going to use the require. uh, so we are going to use the require uh, thing, what's it called, the require keyword, instead of using the import keyword, because this is not type module and I wouldn't want it to be. And we are actually going to install this library, tfjs node. So I'm going to copy that and I'm going to send it in the chat. There is also a tfjs node gpu actually. So there is the node one, and there is so node. Okay, so it basically uses your CPU. So installing CPU TensorFlow JS, or you can actually also install a GPU TensorFlow JS. Uh, and on Mac, like if you're running it locally on Mac, you first require Xcode. I'm pretty sure it should be there. And for M1 chip, or I'm also assuming M2 chip, you would need something like this to happen. And that is why I love Replit. Okay, don't have to go through all of those things. uh, so yeah, let me install the tfjs node. And I actually was trying on Replit if we can run the node GPU. Seems like we can. Okay, at least it was not throwing any error. So but let's do it with just the node CPU one for now, and then we can come back to GPU later. Perfect. So this would be from @ TensorFlow TFJS node. So this is the require syntax, which does exactly the same thing what import does, just in a different format. So this is basically saying import star as TF from TensorFlow slash TFJS node. You are on Ubuntu. I am not actually. I am whatever Replit is providing me, which I'm assuming should be some kind of Linux machine. Const fs file path would be require fs. Okay. So we are going to use this to basically read from a folder, the folder that we are going to upload very soon. And we would also need this path library. So these are two things that we did not install because they come kind of pre-installed with Node.js. Okay. Now we are going to create two variables. One is going to be train directory, like where our training data will sit. So it will be like / training underscore images. I think that's what we name the folder, right? Training underscore data. Okay. We are going to upload that folder to Replit very soon. So like for now, let's just like assume that it exists. And there would be a test dir, which is our testing directory. And I'm pretty sure we named it testing underscore data. Yep. / testing underscore data. Then normally you would resize your images. Okay. The image would be kind of resized or sized to something. So what did we actually, if I want to take it to full length of the image, what was our canvas width and height? I forgot. 256 cross 256. Okay, so we can actually say that let's try this. And const number of classes. So number of classes is how many types of data do we have available. So we actually have only two kinds of data. There is one of a triangle, one of a circle. So I'm going to keep it at 2. So you can think of number of classes as number of shapes, different types of shapes, number of types of shapes. We have a circle, triangle. If someone has done like 3 kinds of shapes, they have done rectangle as well, or 4, like what was that? Hexagon. If you do hexagon, so your number of classes would be then 4. In my case, it's going to be just 2. So now let's create a function load images that is going to be asynchronous. We'll take the directory path as input, and now we'll do const files equals to fs dot read dir sync. Okay, read directory synchronously, read all files in the directory basically, and then create an array. So there would be an images array and then const labels array. Okay, so this will hold the images, the image files, and this will hold the labels of those files. Okay, let me format this and let me actually minimize this part. Not really needed. Okay, and next part would be, so for, now we'll go for loop const file of files. Okay, I think this is a syntax which kind of comes from Java. For the for of, which it recently came to, like, I wouldn't say recently, like yesterday or something, but it has been introduced in JavaScript as well, the for of syntax. Okay, and I find it quite nice. So const label equals to file dot file. For const file of files, file dot split. Split it on, we have a dash in the name, and after the dash, the first bit. Okay, so if we have like one dash triangle, we are going to separate it on dash. So then we'll have an array of 1 comma triangle. From that, we are basically saying take the first part, like first, no, sorry, not first part, at index 1. Index 1 is basically the second part, which is the word triangle. Okay, and then it would be triangle.jpeg. Okay, so it would be like, if let's say we take this thing circle, so it would be 1 dash circle dot jpeg. We are splitting on dash, then we'll be left with, and we are taking the circle dot jpeg. Now we'll split it again on the dot, and then we'll take the word circle. So dot split on the dot, and then take the word, the 0th index, which is circle, the word circle. So extract the label. Then what we will do is we will actually get the full path of the image. So const file path would be equal to path dot join the dir and the file itself. So the current, like the directory where it is coming from, which would be coming from here, which would be basically the train and test directory. Okay. Also, let me actually try and upload the whole folder if I can. Test images, canvas images, new images, training data. Okay. Upload. And upload folder, new images, testing data. Upload. It has 10 and it has 30. Perfect. Okay, so load images, that is done. And then we will create an image buffer. So image buffer is basically saying that read the image, read file sync, file path, okay, the whole file path, and store it in a as a buffer format. Okay, so it is basically your hex a0 a1 x something, not x 1b 0021, like basically kind of a buffer format as it, you can say it. And then we can say const tensor is equal to tf dot node dot decode image. You can also do actually decode JPEG, because we are sure that it's a JPEG image, right? Actually, no, we can't do, because we are converting it to buffer. So it should be, I think, dot decode image, and then image buffer, comma 1 dot resize nearest neighbor, where we will say it should be equal to image size that we have defined, comma image size. Okay, so 256 cross 256 is what it should be. Like if you reduce this size to, let's say, 128, then it should resize the image to 128 cross 128. In our case, I will keep it here, but we'll also, like, I've created that variable so that we can resize it later. Then dot to float, that is to convert the tensor to floating point. Then dot divide it. We have done this, so we are going to divide it by 255, because, well, there will be a color, even though we think it's like white and black, we are not grayscaling it as we were doing yesterday. So dividing it by 255 so that we can normalize the pixel values between 0 and 1. And then dot something called as expand dims, which is expanding or adding a batch dimension. And okay, so that should be it. And after this, our images, the images array that we have created here. So images dot push the tensor, that is the numbers, the image tensor to the array, and the labels is the array that we created here. Labels dot push each label, okay, the label that is created here. And I think that should be good. And then finally, from this function, from this load images function, we are going to return the images comma labels and format. Okay, so can we actually run this and check? Let me try. If I do something like const main is equal to, this would be asynchronous, well, because file reading is not a line by line thing, and there would be other things that would be asynchronous. So I can say const train data equals to await the load images of train dir, okay, and const test data equals to await of load images of test dir, okay, the two variables that we had created here. And I think that should be good enough. Can we, like, after this whole thing is done, actually let's console dot log what is in the train data and what is in the test data. Don't really need this. This should be good enough. Format it, clear the shell. Actually, we can also clear the console, and we need to call main. Okay, so main function being called here. And what would be one good thing is we can kind of, since it's an asynchronous function, there is a error handler that exists on it. So we can kind of catch the error, and we can do like console dot error err. Okay, so we are running the main function and catching any errors if exist. And now we can click on this run button. That should install everything, and there we go. So the train data has images, which is tensor, and the labels circle, triangle, circle, triangle. So individually it's going through each of them and giving the label. So this matches to this kind of. And similarly for test data. Okay, so circle, triangle, circle, triangle, circle, triangle, circle, triangle. So we can actually also do like train data dot images. Okay, so if we do this and I remove the test data from this, click on run again, and as you can see, this is what is coming. Okay, the tensor contains kept false, is disposed internal false, what is the shape of the image, what is the data type of the image, what is the size, what is strides, I'm not too sure how to like what is stride, the ID, the rank type, scope ID, some of the things that even I'll have to check out. Okay, so that's the images. Perfect. And yeah, so we have created the function of loading the images and extracting the name of the image and storing it in the in an array. Okay, and we have seen what does that look like, what that looks like, sorry. And now the next bit, what's the time? It's 3:35. Oops, I only have like 20 minutes. The next bit would be to encode the labels. So const encode is equal to, it takes the labels as the input. Okay, and then we can create something called as a label map, and that would be an empty object. Then const numeric labels equals to, we saw that labels was kind of array, not kind of, we know that it's an array. Sorry, my bad. So label, and then we can say that uh, kind of, let's do a check. So if not label in label map, so if the label already does not exist in the label map, then in that case, in the label map, the key will be the name of the label, which is like triangle or circle, and then object dot keys of label map dot length, assigning a numeric value to each label is what we are doing here. And then after this, we can kind of return the label map of a particular label that is coming in. And then finally, we can return the numeric labels, comma, label map. Okay, formatting this. And let's see what does this return to us. So we saw the train and test data. And now we can kind of do const numeric labels, which we will rename to as train labels. So training labels, you can say, which is going to call this function of encode. What was it? Encode, right? Encode. Should we name it like encode labels? Encode labels, because I'm not too sure if there will be a conflict in the name. So encode labels, and that takes in the train data, which is coming from here, which had the labels param, right? And similarly, we can do this whole thing for test. So this would be, instead of train labels, we will rename it to test labels, and we will pass it the test data dot labels. Okay, now let's console log this. Console.log train labels comma test labels. Okay, formatting it, expanding this, clearing this, running this. Undefined. What? It takes in labels. Yeah, we are creating a label map. Numeric labels. Uh-oh, spelling mistake. Yeah, perfect. Okay, so you are returning. I think I have a wrong spelling of labels. Labeless. Okay, but yeah, say basically I have to keep the same spelling everywhere. Should change it probably. LABELS, labels. Yep. And if I rerun it, yeah, so this is the label. The training labels are 0 1 0 1 0 1 0 1. Why? Because 0 has been assigned to, let's say, whatever was the, I think either the circle was the first, so all the circles have the label of 0, all the triangles have the label of 1. Encoding it to numbers was, well, training, the training model will not understand the name, it needs some numbers. Okay, so encoding labels has been done. Now let's write the train model. So function to create and train the model. I'll also keep my watch open, and let me check which is the next session after this. Give me 1 second, sorry. Oh, there's a Bob Ross mini event after this. Okay, should be able to complete quickly, hopefully. Then we do const of train model. Train model equals to asynchronous. It will take the train images. Okay, so the training images it will take. It will take the train labels. It will take the test images. It will take the test labels. And then once you have that, we will create the const model is equal to tf dot sequential model. A sequential model is any model where the output of one layer is the input to the next layer. Okay, so we will use multiple layers of training. Will like it's like looking at the same thing again and again with different perspective. You can think of it as that way. And whatever you saw in the first, like you saw something at the first time, you returned an output. The output is now going to be used as the input when you see the same thing next time. Okay, so yeah, you can think of it as that way. And then we will do model dot add. In that we will do something like tf dot layers dot conv 2d. Okay, so conv 2d is for convolution. What is a convolution? Now that's a very vast topic, but I'll try to summarize it quickly. So convolution is like a mathematical operation, uh, specifically for image processing. And the idea is that you extract the features of the image, like what does the edges look like, what's the texture, what's the shape, by sliding a filter over it. Okay, uh, so yeah, I hope that makes some sense. Input shape would be equal to, like, it should be image size comma 1. We actually saw that when we had run this whole thing. And the filters would be like, what's the filter size, what's the kernel size, should be, I think 3 would be nice. And activation function is going to be relu or relu 6. There are, seems to be like elu, elu, gelu, blah blah blah, but relu is what's the most used, I think. So relu activation function. Oh, what's an activation function? So activation function is like what's kind of the algorithm, you can say, right? uh, yeah, there are different activation functions. Example like, I think relu, that is rectified linear unit. There's softmax, there's sigmoid, there's tan h, multiple. So it's like legit a mathematical formula, okay, of how to learn, kind of. Uh, okay, then I don't think you need to do anything here. Should add some spacing there. Then we can do something like model dot add, where we have tf dot layers dot max pooling 2d. Okay, and pool size would be like 2 comma 2. So what's max pooling again? So max pooling, you can think of it as uh, something uh, which helps reduce the spatial dimension. You can like basically think of it as, if you have an image which is 256 cross 256, we are saying that break down the image into boxes of 2 cross 2 to learn. So that ways the computational complexity reduces. Okay, and there's no overfitting, like it helps reduce overfitting problems. So that's your pool size. Format that again. Then you can do model dot add. I don't think I'll be able to complete it. I'm going to actually copy it from what I had written previously. So flatten the dense units, the rate, the num classes, the activation, the compile. Uh, so all of this have are related to activation function. Okay, so basically, as I said, that it's like you're looking at the same thing again and again. Uh, just like whatever is the output of this first time, you take that as the input to the second time and stuff like that. Okay, and finally, you do something called as compiling the model, where you are using a optimizer, which is something that you can look up at TensorFlow. Uh, you are also plotting the accuracy. Then you can kind of summarize the whole model and plot it. And then what else? There's the training, the Y train X training data, the testing data. Then you are the fit is what starts the training. Okay, so model.fit is basically telling it to start the training. So everything that you have done till now is to tell it how to learn, but this is the part where it actually starts learning on the training data. Okay, and where X is basically your images, the Y is your labels, the like mapping between the image and the label. Epochs is how many times it needs to rerun. Okay, like relearn in a way. Batch size is how many images at a time. Validation split is whatever images it takes in as an input, you split that data for validating whether it's learning correctly or not. Okay, so it learns like one time and then it checks its understanding. It's like taking your own test. So we have done copied everything till model summary. So need this, and line number 91 is where we are saving the whole thing in a model folder. Okay, model.summary, and yeah, model trained and saved, but we have still not called this whole thing. So what we do is we can go here and call this thing. Console.log can be removed, and this thing, format, and clear everything. And now let's start running it. So as you can see, there's no there's no model folder here on my left hand side. So now I'll start running and hopefully there's no errors. And it starts training. Okay, epoch 1 of 40. And something happened. Oh, did I hit the limit? Hope not. Also, you can find all this code on this particular link that I have shared. I wonder why. Hmm. Can I do like node run index.js? Maybe that would help. Killed. Okay. I don't think Replit is going to allow it to run. Maybe there is some problem there. Let me refresh this whole thing. Maybe that would help. But ideally, once you get your model, okay, it's getting killed again and again, and I wonder why. Yeah, what if I try and run the old one? Let's see. What is this using? It's using TFJS node. Okay. I'm not too sure what's the difference. It's exactly the same thing. No idea. I just had like 3 classes before. Okay, and at the end of it, you can see that the model actually stores with like 34% accuracy, like just 34% accuracy. And ideally, this should be the code that does it. Let me copy this whole thing, come over here and paste it. I think the image size is the problem. Uh, the number of classes will be 2 in this case. And let's check if the image size 28 helps. I mean, that's the only thing that I can think is causing the problem. Oh, there's no train images, is called training underscore data. And there's a testing underscore data. They contain the images, right? Yep. And run this. Okay, so 256 cross 256 is a very bad idea. And my model actually now has 100% accuracy. So it is definitely overfitting. Okay. If I try 64, running it like 40 times may be a bad idea. Could reduce it to like 20 or something. But you can see that my accuracy has actually reached like 100%, which definitely is bad. But it creates this model folder, which contains the model.json and the weights.bin file. And that is what you actually need to deploy this, okay? So all you need to do then is create another app where you can use this model, okay? So we can kind of go back to what we had before, the create your own ML dataset. Inside this, we can create a predict component .jsx. Inside the predict component, I can actually kind of import use ref comma use state from React, okay, and import star as ef from @tensorflow /tfjs, okay. And then we can create a prediction component. So const predict component would be something. Let me also, it needs the model, right? So the model that is here, I would need to copy that. I don't know if it will allow me, and save it inside the public folder. Okay, apparently not. So I can create inside the public folder a model folder, and inside that folder, I can kind of now copy this file. Can I please add a file? It will be called as model.json. And let me copy this whole thing, paste it here. Then the weights.bin. This is definitely not something that you can copy. So I'm going to download it in the circle folder it's going, or new images folder. Okay, weights.bin. And here I need to upload the file, add file. Upload file. Okay, perfect. And then new images weights.bin, and that should get uploaded right here. Need to move it inside the model folder. So inside the public folder, I created a model folder which has the model.json and the weights.bin, the two things. This is our component kind of, which kind of got repeated, the predict component. And now I am going to use that in my app.jsx. So I'm going to comment out the draw component, and I'm going to use the predict component. Comment this out, and I think I need to install the tf.js. So I'm going to go over to the shell, and I'm going to do npm I tf.js. And while that in like it actually, I'll have to wait for it to install. Also, I'm so sorry. I'm like I had told you that this would take more time. We had less time for this. So, but the code will be available. So the create your own ML dataset. That's where you can find the code to this part. And yeah, once this gets installed, let's run it quickly. Come on. Meanwhile, if you have any questions, please put it in the chat. If not, well, that's good. Well and good. Let's see if this can predict it. And predict shape, it's predicted as circle. Okay, and if I draw a circle, predict shape, that's a circle. So our model is not really good, it seems. Okay, definitely overfitted model. So something that we would need to look at, maybe have a better, more data would be nicer. Maybe something like a thicker border here would be nicer. But in general, that's how you can create a model, and that's how you can use a model. Where have we used the model? So this is the thing that is the main aspect, which is loading the model, where you do tf.load layers model from the folder. Okay, and this is where the prediction is happening. Everything else is kind of what we have done previously, like the button styling and everything that we did in the draw component. So exactly the same thing. Okay. And yeah, that's the end of the session. Hopefully there are no questions. Enjoy the next one. And sorry, this had to be rushed, but I think the previous 3 sessions were nice enough, where you learned about using Coco SSD and test extract and stuff. And in this one, the code is there. Needs definitely some kind of changing. Okay. Not this one. Yep, this one. Okay, it needs some kind of changing, some kind of formatting. You not formatting, like the activation and stuff, you might need to check what could be done, what could not be done. Because 100% accuracy, that is bad. That is definitely bad. Maybe it's not learning then. Adding more data, that should also help. And yeah, these things should be helpful to create a model which works perfectly fine. And we finally end up with this whole predict component. I actually borrowed this idea from someone called Charlie, whose blog I found, Charlie Gerard. So this project is an idea that I got from that blog, and then I built from there. Okay, cool. Hope you all enjoyed it. Thank you so much, everyone, for joining, and bye-bye. See you. Cheers.